So chapter 16 is about chemical equilibrium. The quote here, every system in chemical equilibrium under the influence of a change of any one of the factors of equilibrium undergoes a transformation that produces a change in the opposite direction of the factor in question. And that's a quote from Henri Le Chatelier. And hopefully you remember at least hearing about Le Chatelier's principle. And we will be discussing that more in detail in this chapter. So we just finished a chapter on kinetics. Kinetics has to do with the speed of a reaction, how fast it happens. The extent of a reaction is thermodynamics. The equilibrium constant K is something that we determine experimentally, and that tells us how far does the reaction go. Do all the reactants react to make products? Do only a little bit react? Is it like half and half? In Chem 1A, we kind of assume that all reactions go to completion, and that is actually not true at all. Most reactions do not go to completion. They'll go to an equilibrium state. So that equilibrium constant tells us how far it goes. If we have a large equilibrium constant, that means that the reaction favors the products, and we're going to end up with more products than reactants at the end. If we have a small equilibrium constant, that means that the reaction doesn't go very far, and we're going to have more reactants and not as much products at the end. So in chapter 19, we're going to talk more about thermodynamics and explain some of the reasons for the magnitude of the equilibrium constant. Why is it big? Why is it small? But we're not going to worry about that in this chapter. So let's talk about hemoglobin a little bit. And I'm not going to test you on hemoglobin. This is just an illustration. So you probably know your red blood cells contain a protein called hemoglobin. And this is what interacts with oxygen and allows your blood to carry oxygen. So we can do a little simple equation here where we have hemoglobin, HB, just to stand in for that big mess, will react with oxygen and pick it up. They'll be stuck together. Here we have double arrows, and that indicates that this reaction goes in both directions. The hemoglobin can pick up the oxygen, bind to it. The hemoglobin can release the oxygen. That's a chemical equilibrium, the reaction occurring in both directions. So the equilibrium constant K is going to be a factor including the concentration of the products and the concentrations of the reactants. In equilibrium, systems respond to changes in a way to maintain the equilibrium. The equilibrium constant is a constant because if you alter some of the concentrations, it's going to shift around until the equilibrium constant is restored. Okay? So in your lungs, you have a relatively high concentration of oxygen because you're breathing in fresh air. So the hemoglobin in your blood is exposed to this high oxygen concentration. The reaction shifts to the right. As the blood flows into your muscles where the oxygen concentration is lower, lowering this concentration causes the reaction to shift to the left, and the hemoglobin releases the oxygen. And so this is a really cool way to deliver oxygen in your body. It picks it up in the lungs where the concentration is high. When it gets to a place where the concentration is lower, it releases it, and then as it comes back to your lungs, it can pick up more oxygen. When we think about an equilibrium, there's a balance. And when we upset the balance, the reaction will shift. So there was a balance between hemoglobin and free oxygen and hemoglobin bound to the oxygen. In the lungs, we've increased the concentration of oxygen. I like to think of the equilibrium as kind of a spoiled child. And you do something to it, and it's like, I don't like that, right? And so you're like, oh, here's more oxygen, but I didn't want that. So I'm going to shift over here. I'm going to shift to the right and use up some of the oxygen you gave me to make it the same. Of course, it can't make it exactly the same, but it's going to shift in a way to minimize the changes. So it shifted over here. Then it comes to where the muscles are and the low oxygen concentration is lower. It doesn't like that either. And so it's going to shift this way to release oxygen and increase that concentration. So when you do something to an equilibrium, it reacts in a way to at least partially undo what you did. I kind of relate to this because I don't like change unless it's my idea, right? If it's my idea to rearrange the living room, this is great, but I don't want somebody else coming in and doing that stuff for me, right? So I kind of relate to the equilibrium. Any questions? How does an unborn baby get oxygen? Well, the unborn baby has a special kind of hemoglobin called fetal hemoglobin, and this has a larger equilibrium constant, which means that it will pick up oxygen at lower concentrations than the adult hemoglobin. So the mother's blood and the baby's blood do not actually mix at all, but the veins and arteries come very close to each other. And so there can be transport of oxygen from a vessel to another vessel. So the fetus is getting oxygen from the mother's blood, even though it doesn't mix. So the fetal hemoglobin will pick up oxygen that the normal hemoglobin is releasing and bring that into the baby. Kind of cool. Any questions?